What is TCP IP? Well, this is a suite of protocols that is used on the internet to communicate, meaning that when we are communicating with other devices using the internet or a given network in general, we are using this TCP IP protocol suite. So, this is a common language that devices have implemented such that they can talk to each other, because if we didn't have these common protocols, then two devices did not know how to communicate with each other, because you just can't take a copper cable and connect two devices and then expect them to figure this out on their own. They need some basic language that they both understand in order to communicate. Similar to us humans, we need to have a language that the two of us understand in order to understand what the other one is saying. So, the first one, TCP, which is Transmission Control Protocol. This is one of the protocols. There is also UDP, which we're going to discuss later. But for TCP, it is a verified delivery to endpoint protocol, meaning that, as we see on the picture right here, when two devices are communicating, here it's Bob using his computer and Alice using her computer, then when they are communicating with each other, Bob is first sending a request or some kind of package to Alice, then Alice acknowledges this, and that is where TCP differentiates itself from UDP, because every time a package is sent, the receiving part is acknowledging the sending request, and then the flow continues where we send something and we get an acknowledgement back. And this TCP protocol is used within, for example, POP3 and HTTP. So these are some protocols that uses the TCP protocol to work online. We will see a map in a few slides so that you can get a bigger understanding of how all this is connected. But first, the IP, Internet Protocol. This is the protocol that allow us to go one step above the MAC addresses, which we discussed in previous lectures. MAC addresses is used in, for example, and hubs. When you connect devices, then they use the MAC address to remember who is sending what and to who, because without IP addresses, we can only rely on these MAC addresses since they are hard-coded into our network interface card. But this will only work on our logical network. But as soon as we go beyond our logical network, meaning that we are communicating through the router out to the global net, we need the IP protocol, because then we need to have IPs in place in order to understand what device we're going to speak to and what route we need to take in order to get to that device. So this is basically what the IP protocol does. And if we see on this picture, we have a more basic overview of some of these protocols. So as you see right here, we have the OSI layers, which we discussed in lecture 1. So we have our application layer at the top, and then we have our data link layer, and this is supposed to be a 2, but yeah, you hopefully understand it. So as you see, we have the TCP on our layer 4, and we have the IP on our layer 3. This basically means that TCP uses the IP protocol from layer 3 to do some other protocols. For example, it is used by DNS and POP3 and HTTP and so on. These are just some of the protocols. There are many more. You can feel free to look them up yourself in order to get a full list of all the protocols. And then we also have UDP, which also relies on IP. But as I mentioned, whereas TCP uses acknowledgement on transfer, this one just pump out messages and don't need any confirmation that such a package has been delivered. And this is used on our DHCP servers. So this is a little overview of how these different protocols are connected and how they are laid out in the OSI model. So some of the protocols that you just saw on this map were, for example, the ARP address resolution protocol, which is this one right here on our data link layer, layer 2, remember this? and that is basically used to map the IPs to MAC addresses. Then we have the TCP UDP here, as we discussed, where TCP confirms delivery and UDP just keep delivering without a receipt. Then we have the DNS, which anyone using the web and who has been surfing the web have been in contact with, because DNS is basically what helps us resolve the endpoints and domains that we type in. For example, www.google.com gets translated into our IP address in order for the computer to understand what exactly we are doing. So that is why DNS is very important when we are using the web. And then we have the DHCP right here, which is basically the protocol and server who hands out IPs on our local network. So when a computer connects to the network, this part will take care of handing out IPs such that we can have more than just our MAC addresses. So this was a short introduction to TCP and IP. We are now going to go a lot more in depth with these protocols, especially TCP and UDP, and what differentiate them and what the benefits are of using one above the other in certain context.